Welcome back. This time we're going to actually take a look at how we can use C++ to define any kind of data type and define methods that are operators in general, which is something that's quite useful to actually come up with an abstract data type, and we'll define operators that can be prefix, infix, postfix, anything we want. So let's get going, and we're going to actually develop this code together for this time. Some of it will be on the slides in a second, but for now, let's stick to a clean definition from scratch. So what I want to do is define complex numbers. So you can fairly easily understand what I want. You know that a complex number is something like alpha plus I beta, right? This is what I'm after. I want to have a number like this, which you can represent as a pair alpha beta. If you have that pair, you know exactly what you mean. Now, recall that there are a couple of rules. If we have addition, if I have two complex number A and B that have this form, doing A plus B is the same as, since A is alpha 1 plus I beta 1, and then B is alpha 2 plus I beta 2, doing the sum of these two entities is none other than doing alpha 1 plus alpha 2 plus I beta 1. Oops, I'm in the writing, sorry. So I'm going to put it underneath, right? Plus I times beta 1 plus beta 2. That's the kind of thing I want to do, right? So, and there are a couple of rules. There is the notion of what is a conjugate, what is a product, and whatnot. So we want to build that up, right? And build an implementation for that. So what I'll do is go inside my text editor, and we'll do that together. So let's load up first a file, complex1.h, because of course I already have the solution built up. And we'll start by saying that if there is no macro called complex1, I'm going to define complex1. And this is the end of my file, right? So once this is done, the first thing is to define a class for complex numbers. That is, you see that I'm making the skeleton and then I fill in the details, right? So I know that there will be some attribute and there will be some methods that are public. So what do I want? I probably want a default constructor, and it won't do anything interesting so far. I'll probably want to have also a constructor that takes my alpha and my beta here. So I could say, I will take a double, which is A for alpha and B for beta. And these are the fields, and I need to actually save them. Now, it means I need to have state variable, and I will call that the real part and the imaginary part, right? So that's exactly what you would expect in that case. So I would initialize the real part with A and the imaginary part with B. And then there will be nothing else to do. So in that case, it means that the real part, if I want to be nice and initialize, it should be 0, and the imaginary part should be 0 as well. Okay, that's cool. So at least that gives me a way to build a complex number with a custom constructor and a default constructor. I will probably want to have a copy constructor, so I'm going to actually put it directly. A complex C that will initialize real with C real and imaginary with C imaginary, and then there is nothing else to do. Great. We are done with the copy constructor. If I want to support assignment, I probably want to do that too. So let's add complex reference operator equal that takes a const. Remember, that's the requirement, right? I have to have a const complex reference, C again. And what we're going to do is quite straightforward. It's just assignment of real to C real and imaginary to C imaginary. Once I've done that, I should simply return a pointer to myself, or what the pointer to myself is pointing to. And I'm going to indent it like that so that it's a highly readable constructor. Okay, great. So now I have my assignment operator. Destructor here, since I'm not allocating memory, I don't need one, so I will let the compiler produce one for me. I'm not going to agonize over that. But then I need to implement things like that, like addition, like conjugation, and whatnot. So let's do that. So what is addition? Well, addition will return a complex. We'll call it add. And this is a method on a complex. So I'm a complex, and I'm asked to be to add something else to myself and then return that as the result. So add will take in argument the second complex. So again, I don't want to touch it. It's going to be read-only, and I'm going to call it C2 to remember it's the second because the first is me, right? So if I do that, what am I going to do? I'm going to simply compute the sum of the real and imaginary parts. So I will take my real part plus the real part of C2. I will compute my imaginary part I as my imaginary part plus the imaginary part of C2, and once this is done, I should simply return a complex that is none other than, than R comma I. That's it, that's addition for you. Now I can do the conjugate of a complex number. That's the same idea. You know that it's quite straightforward if you remember your basic math. The conjugate of a complex number is none other than the number with the imaginary part flipped, sign-wise. So I would return a complex which has the same real part, but its imaginary part is negated. That's it, that's a conjugate. Great! Notice that here the implementation are so short, I don't even bother putting them out of line. I directly provide them in the header file. We can maybe change that later on. But that's a good start. So I can compute a conjugate, I can add, we could do multiplication as well. This is not all that critical, but I have the mechanics up and running. Maybe I'd like to be able to print myself. So let's say that I want to print, and print, of course, would actually go to an output stream. OS. So if I want to have that, clearly I need to include the output stream header file, otherwise this is not going to work. So I include those stream and I fully qualify it since I've never said using namespace std anywhere. So once I have that, I can say complex1 cpp. I'm going to implement this print out of line. Here I'm going to include complex1.h. And once this is done, I'm going to implement that print method. So let's take it, copy, go back to the other file. It's a method of the complex. And what do we do here? We're going to say OS. Now I'll print, let's say an opening parent. We're going to use parenthetic notation. And who am I printing? I'm printing myself, so it's my real part. And then I'd like to print my imaginary part. Now the imaginary could be positive or negative, so let's try to print something that's kind of neat like that. So rather than saying alpha plus I beta, if beta is negative, it would be better to write alpha plus beta I. Let's write it that way. So I could say, for example, if beta is negative, then we print the real part. Then since it's negative, I don't need to put a sign, right? I can directly put, say, a blank, then put my beta, and then put the letter I. Now, after this is done, I can close the parenthesis and I'm done. Now, if beta is not negative, beta could be 0, in which case there is no imaginary part. So rather than printing 0 times I could say else if beta is none other than 0, which is an easy test to do, then let's just print the real part and we forget about anything else. Finally, if I'm neither negative nor 0, I gotta be positive. So in that case, I'm going to actually print my real part, followed by a string, which is a white space, the plus sign and a white space to be nice and readable. And then I will put my imaginary part, and I will finally place the letter I and the closing parent. And that should do it. Great. So we have an implementation of printing that should be fairly sensible. Great, great, great. So let's go and load now a test file. So we'll call it testcomplex.cpp. Here we will include complex1.h, the one I've just written, and we'll go ahead and write a main function. Now my main function is going to do what? I'll create a complex, let's call it A, or C1 for example, and I'm going to give him a real and an imaginary part. Then I would give myself a complex C2, and let's give it a real like 3 and an imaginary part minus 4. And then, for example, I'd like to compute a complex C3, which is going to be the result. So I would say C3, and C3 is what? It's the result of an expression, which is an addition. So let's try C3 equals C1 dot add C2. Now I want to see whether everything has worked out correctly, so I'd like to invoke the print method on C1. Oh, if I want to use cout, I'm going to say using namespace std to save myself namespace std to save myself the aggravation of typing all of that, and I got to include iostream, because of course that's where it's defined. So I would print C1, and let's be nice, we'll say that this is C1. We can even leave it behind like that. Now let's use that line to print C2 and C3. C2 and C3. Finally, I just print return 0 to say we're done, and that's all there is to it. So now let's go to the shell, and we're going to compile all of that. So go at the end. First, let's compile complex1.cpp. I want to just compile and not link. And I'm going to use the C++ standard 14. And let's have debug information just in case. Of course, he complains I've made some mistake. He tells me first in line 5, you're talking about a beta. Who is that? He says, like, I don't know who beta is. Why? So let's go, sorry. Complex1 CPP. And here I say in the if beta, okay. That looks okay, I'm inside the class, so what did I do wrong? Well, what I did wrong is kind of obvious if you've been paying attention. If I go to student1.h, no, not student1, complex1, is that the fields are not called alpha and beta, they're called real and imaginary. That's my problem, right? So the test here is really if the imaginary part, then I don't want to see beta, I want to see the imaginary part. Now, if the imaginary part is 0, then we only print the real part, else if I print the real and the imaginary part. Okay, that's better. Let's go back into the shell and try to compile again. So I repeat the command, and this time it worked. So now I'm going to compile, we called it test complex. Just compile, same thing, the C++ standard 14. And let's have debug info, no complaint. So let's link complex1.o with test complex.o, should be there. And then let's send the output into tc for test complex. He doesn't complain, ls-l tc, yes, I have an executable, right? So now I can run tc. And what do I get? Well, I get a printout that's not very readable because I'm missing n lines. But we see C1, C2, C3, right? You see all of that down here. On this specific line, we have what we want, right? So let's print that a little more nicely. So we'll go back to test complex, and we'll say, oh, well, let's put an n line after each one. And I'm going to actually duplicate that 3 times. Now I'm back in my shell. I recompile the test. I relink, right? I don't need to compile the other guy, so I relink. I run tc, and now I have a nice output. It's telling me C1 is 1 plus 2i, C2 is 3 minus 4i, so the result is 4. 2 minus 4 is minus 2. It's 4 minus 2i. So it worked. It worked. It worked. It worked. It worked. We're quite happy with the result. If it weren't for the fact that the code is ugly. It's ugly as hell. I mean, look at this. I create my 2 complex, and here I have to call C1 add C2. Come on. I mean, when I'm manipulating addition of complex, I wrote it here, I use the plus operator. I'd like to reuse operators. I'd like to see these objects, complex, just as if they were values, like integers or double. I want to be able to use operators. That's what we're going to do in the next video. See you in a second.